So LIDAR is pretty, this is like my baby. I get really excited about it because this is my research. So LIDAR, as Shelley said, is this really cool technology where you use laser scanning from aerial LIDAR. You use an airplane, you fly over an area of interest and collect LIDAR data. It basically turns things into a point cloud. But this is what I was basically focused on for my research, was this research question: will using the LIDAR topography data instead of or alongside traditional visualizations and teaching methods enhance a student's ability to understand geologic concepts such as plate tectonics, the earthquake cycle, strike-slip faults, and geomorphology? So this was what I was trying to study. And starting out, why are we using LIDAR? Can't we just use photos? Because, you know, and the problem is, and I'll show you in a second, photos are a great supplement, but using the most recent technology can actually get at problems that photos can't. And we'll use LIDAR. I'll show you how you can use LIDAR topography to tackle sort of concepts and geoscience education that you can't do otherwise. So here's how you collect your LIDAR data. So you collect it on the ground with this laser. Basically what happens, the laser leaves the plane, hits the ground, and comes back up to the plane, and you collect the timing that it took for that light to bounce back to the airplane. And then using that, you can interpolate how long it took make that into the XYZ sort of spatialization. So you get data back that kind of looks like this. So these are where the laser hit and then bounce back. So you have kind of these higher bounced ones that kind of hit off trees and other objects, buildings, and then some of the laser light actually goes all the way through to the ground and comes back. So we call these top ones the first returns, and then the rest of them are second, third, etc. returns. It takes a little bit longer for them to get there. So this is one of the cool things that LIDAR does. So here is an area that was scanned in Washington. So you can see it has all these trees, and we removed the first returns here, and you can see completely under all the trees without actually chopping the trees down. So you can see the landscape and get to it, and that allows geologists and other scientists to do things like map faults. So now that the trees are gone, we can see the fault scarp and the lineations in the landscape, and now we can do science. You can also have ecological or other applications where you can map back these point cloud returns. So here they've mapped back the canopy heights of the trees, and you can use other, not in my specialty, but there are ecological applications to doing stuff like this. It's also interesting when flying LIDAR to see how close houses are to faults and things like that. And this creates kind of a real impact on students. In California, I know there were people who are using LIDAR to show, we only take the swath so long, on the San Andreas fault or other faults, and you can see, oh wow, there's a house that's right next to the San Andreas fault that's built here, and it kind of helps students even think about, wow, where should we be building these things, which is cool. So we had this hypothesis that LIDAR was going to be better, we were hoping. And we tested it at ASU with Wendy Bohan, who's part of the office, so we worked on this together, and had 25 students look at aerial photography, and then other students looked at LIDAR. So we used a couple of examples. One of them we used was Wallace Creek, where this is on the San Andreas Fault in California. There's not a lot of infrastructure. There's distinctive vegetation patterns. You can see that here. And there's clear stream offsets, and we wanted to see if students could identify the fault or not. Also, we use this area in San Bernardino County in California that's a lot more complex in the aerial photography. It's really hard to see the scarp that you see here in the LIDAR. There's much more landscape, and there's lots of infrastructure, roads, and other various lineations, et cetera, that are complicated. And we decided to see if students could identify things. So we had students look at it, and here's the Google Earth imagery for Wallace Creek results, and then here it is with the LIDAR. We had students see if what they would say, I think, was the most prominent feature. So here they said land use. They chose something that was related to land use as the most prominent feature. Landscape things did not come up, but here, something in the landscape was what was most prominent to the students about the imagery they were looking at. So this kind of changed them from focusing on vegetation or buildings or roads or whatever, and really look at the landscape and not be distracted by other things in the photography. These are college students that are looking at it. So I think we used all Geology 101 students, so they were just beginning to learn about geology. They were very novice learners. So yeah, but it wasn't little kids or anything. These were more, well, it was ASU, so there you go.
Did the LIDAR have the vegetation on it, or was it the one that you just showed us that didn't?
It does have the vegetation on it, so we did not remove anything. The B4 LIDAR, we did not remove the first return. So it is a desert landscape, but there is some vegetation. But we didn't even remove it on this processing. So in San Bernardino, everybody identified something from the landscape, and other people were distracted, 60% in the Google Earth high-resolution photos. And then we asked them to find the fault. So students that were looking at the Google Earth imagery, only, I think, 20% of students correctly marked the fault. But in the LIDAR at Wallace Creek, 58% did. In the San Bernardino one, nobody found it, and 11% found it in the LIDAR. So it was still difficult, but there are a lot of distractors in that. Yes. So basically from this study, we concluded that LIDAR hillshade images allow these novice learners to focus on the landscape a little bit more. Obviously, there might be some debate now with Bob on that. There's the Google Earth high-resolution images did have distractors that kept them from focusing on the things that we wanted them to focus on in the activity. LIDAR images helped them identify the fault correctly, well, increased that. So we said, oh, we should be using LIDAR to teach students about earth science concepts. This is a cool new thing. If scientists are using it, we should be using it to teach novice learners of earth science on how you apply that.